So now we'll discuss about the pH of blood, measurement of blood, PCO2 and PO2. So the pH of blood, that is pH scale is acid-base scale, runs from 0 to 14, and the solutions with a low pH have high concentration of hydrogen ions and are acidic. And the electrodes for blood pressure measurement is several types of electrodes has been described in literature for measurement of blood pressure. So micro electrode for clinical applications, and the electrode is enclosed in a water jacket with circulating water. Capillary is protected with a polyethylene tubing. An accuracy of about 0.001 pH can be obtained with this electrode against a constant buffer. Several instruments offer the ability to measure pH in small containers with as little as 250 microliter of the sample. Temperature coefficient of pH of blood is 0.0147 pH unit per degree centigrade, and a buffer solutions primarily used for creation and maintenance of desired stabilized pH of the solution, that is standardized of electrodes chains for pH measurements, and buffer solutions are characterized by their pH value. This is the microcapillary electrode for measurement of blood pH. So here there is a aspiration tube, heating resistors, capillary tube, sample catheter, and the thermometer, and pH sensitive gas heating indicator lamp. So normal blood pH levels is between 7.35 to 7.4 and 7.45. Changes in the pH blood level is, so the pH of blood can changes in both directions. Acidosis occurs when the blood is too acidic, pH below 7.35. So here is the diagram. 7.35 to 7.4 is normal blood pH range. 7.2 is acidosis. 7 is it causes to death. There are four main ways in which blood pH can change. That is metabolic acidosis, respiratory acidosis, metabolic alkalosis, respiratory alkalosis. So this is reduced bicarbonate or increased acid levels is metabolic acidosis. When the body removes less carbon dioxide than usual, that means respiratory acidosis, and increasing bicarbonate or reduced acid levels is metabolic alkalosis, and when body removes more carbon dioxide than usual is respiratory alkalosis. Next is the measurement of blood PCO2 and PO2. Measurement of PCO2. So it is expressed in mmHg related to the percentage, that is PCO2 is barometric pressure minus water vapor pressure into percentage of CO2 by 100. So it basically consists of pH sensitive glass electrode having a rubber membrane stretched over it, and this technique is based on the fact that dissolved CO2 changes the pH of aqueous solution, and the resultant change in pH is thus the function of CO2 concentration in the sample. So in construction worked out by them, the water level was replaced by a thin film of an aqueous solution, sodium bicarbonate solution, and the CO2 from the blood diffuses into the bicarbonate solution. So the pH falls by almost 1 pH unit for a 10-fold increase in the CO2 tension of the sample. So they used a dilute solution of sodium NaHCO3. So silver chloride reference electrode was replaced by calomel cell, which was made an integral part of the electrode. So here is the diagram. You can see lead reservoir, electrolyte reservoir, pH sensitive gas, membrane, nylon spacer, fill hole and fill hole cap. Next is the measurement of PO2. So here the partial pressure of oxygen is usually measured with a polarographic electrode. So in this voltage range, it is observed that the current flowing in the electrochemical cell is proportional to the oxygen concentration of the solution. Electrode is a single unit construction and contains the reference electrode also in its assembly. So here is the diagram. You can see electrolyte reservoir, lead membrane, silver and silver chloride anode, platinum cathode, and reservoir fill hole. Oxygen from the blood diffuses across the membrane into the electrolytic filling solution and is reduced by the cathode. The principal advantages are sample size is required is extremely small. The current produced due to PO2 at the electrode is linearly related to the partial pressure of the oxygen. The response time is very low, so the measurement can be made in seconds. So the measurement of current developed at PO2 electrode due to the partial pressure of oxygen presents spatial problems. So here the field effect transistors usually form the input stage of the preamplifiers. This is the current amplifier for use of PO2 electrode. Has output to a digital voltmeter and various number of resistance and silver chloride solution. So increase of PCO2 is caused by pulmonary edema, obstructive lung disease. Decreased means hyperventilation, hypoxia, anxiety. So elevated PO levels is associated with increased oxygen levels in the inhaled air, polycythemia. Decreased PO2 levels is decreased oxygen levels in the inhaled air, anemia, heart decomposition, chronic obstructive pulmonary disease, hypoventilation. Thank you.